Right, to understand quality of service, we got two routers, one switch, two computers. We'll start configuring from router 3. Yeah, no need of rollback. 10, 10, 5, 3. Ten, 23, 23, 3. Then I'm going to have a default route, IP route, any network, any subnet mask, send to 10, 23, 23, 2. And okay, one more thing. I'd like to give host name. And next is router 2. Alright, Ethernet 0, 0, here is 2. And 0, 1 is 10, 10, 4. And the default route will be 3. This is on router 2. Done. Now, on the switch, I do not want to do anything as of now. Let me go to PC on the left. Mask is 24, the gateway is 10, 10, 4, 2. Now let me try pinging 10, 10, 5, 3. I'm expecting yes, ping. Likewise, let me go to PC5, assign the IP address. 24, 10, 10, 5, 3 is the gateway. And let us try pinging the next endpoint device. It is reachable. Okay. So ICMP is tested very well. Telnet, let's just telnet. Telnet 10, 10, 4, 2. Telnet is okay, and the command is not telnet 10, 10, 4. Or maybe this is not a supportable command in this. And how do we tell it? Remote login. That's the command. Or login 10, 10, 4, 2, 23. We did not enable telnet. We'll enable telnet first. Go to router 2. Line with UI 04. Transport input telnet. Login. Local. Username 123. Password 1. Why is it coming out? Get out. It's not coming out. Why? Oof. What should I do now? Not coming out. How to exit? The reason why I tell it is I want to send a different type of traffics, not only ICMP, to test the QoS. That's the reason I was checking whether the telnet is possible. Control Z, control Z, control X, control. Oh no. Okay, so no problem. I will close this and stop this. Show IP 10, 10, 5, 5, 24, 10, 10, 5, 3 is the gateway. Save. Now ping 10, 10, 4, 4. Spinning. Or login. I'm picking from VPC 5. You see the title here, VPC 5. Remote login 10, 23, 23, 2. Okay, good number. Telnet to port at IP relates to host PC to attach to the console or the virtual router running on port. What is this? I don't think it is a port. So no problem. I have some other ways to do this. Otherwise, start. All right, so let's begin. First of all, we are going to test the marking. Now, whenever this PC on the right tries to ping the PC on the left, right to left, I want to mark the traffic with high weightage. I'm just marking to an ICMP traffic. In the real world, we don't do that. In the real world, a high preference is given to the time sensitive UDP voice traffics. But here we don't have such traffic, so I'm just using ICMP as a match criteria. If ICMP matches, then the marking need to be done to the packet. Before I configure that, let me go to R3 and show you how it looks before configuring. Before configuring, when I say show policy not on interface Ethernet 01, you don't see any policy. Now, I went out to 3. I'm going to write an access list 101 permit IP going from host 10, 10, 5, 5 to the host 10, 10, 4, 4. So this is what I'm going to match in the class map. Class map, I'll say ICMP, ICMP, or class map PC, PC right to left, some name, and match IP X, IP, match IP, match address, match. You also have source address as an option, but I want to call the access list. Match access group. Match access group 101. When the match is found, action need to be taken. That you need to do in the policy map. So far, do show run section class map. This is what we have done. Just one class map calling the access list. Now you see, policy map, you can use the same name if you want. Usually I do that so that I will know which class, which policy map works together. But for now, I'll say ICMP or PC to PC. Some name. Now I call the class map. You see, I have inherited the class map down here, and I have a lot of option to do. I can put it in a priority queue. I can put it in a queue with a limit. I can use random early detection method to drop. We'll talk about these things later. Now we are just doing a sample QoS configuration. I can set bandwidth. I'm not interested in all these things. I'm interested in what we have learned. We have learned IP precedence, COS, and DSCP marking, isn't it? So I want to only mark this traffic. So say set and put question mark. You see, after putting set, you have precedence, you have COS, you have DSCP. Don't care about frame relays and all. This is old technology. And you know MPLS. If you want to set it for MPLS, you remember in MPLS also we have 3-bit reservation for QoS. Hello. Do you agree with that? Hmm. What is the size of MPLS header? That is label. Label size is 20. MPLS header together is 32-bit. Hello, 32-bit. In that first 20-bit is label, and followed by you will have 3-bit. That is what here you are going to say. Okay, if it is MPLS traffic, then you will say MPLS traffic, the experimental bit, and you can go with precedence value, the 3-bit. But we are not doing now MPLS, and you can say COS marking, or you can say, let me say COS. You see, you have 7 different probabilities. How? Because you got 3 bits, no? We got 3 bits. So in 3 bits, you have 7 different probabilities. and I'm going to say 5 for this. I have marked it as more important traffic. 5 is really important. Right. So in precedence also you will have okay, that is going to different. This is different operating system. Now we have already set COS. Now let me show you what we have configured. Show policy map. This is what the policy map configured. Show class map. This is what the class map. Remember, there will be always a default class called a class default, which will allow any traffic without any change. Now, we are seeing here class map and policy map, and the show commands are very simple. Show class map, show policy map. But we have not applied this. Let's apply it. I'm going to apply on Ethernet 00. So, interface Ethernet 0/0. As the traffic comes in, I want to apply. So this is not only for ICMP, for all traffic. How do I know that? Because in the access list, I did not say ICMP. What did I say? Show access list. You see, for all IP traffics, going from this to this, I'm going to give high priority. Assume that this is a IP phone and this is another IP phone. Between IP phones, you will definitely give high priority, always. So assume this has 2 IP phones. Now I have applied this. Did I apply? No, I have not applied it. Interface Ethernet 00. IP, sorry, service, no. Don't put the space. Service policy. Now the traffic is coming inside, no? It's coming inside, isn't it? I'm applying this on E00. No. Look into the access list direction. Traffic is coming from, God bless you. So it is inside, no? Coming inside the router. So say inside, correctly you should say. And what is the policy map name? This is the policy map name. PC to PC, yeah? Okay or yes? Yeah. And it has got class map. If the class is matching, it will set 5. Let us now call this. That's it. Oh, COS is not supported in the input policy. Okay, no problem. I'll go to the output policy. See, this is a router, so it is not supporting COS on the input, only on the output. So I'll go to interface Ethernet 0/1 and I'll put the same command. I should say out. COS supports only on the trunk interface. This is a router, no? If I have a sub interface, then it would have supported. You remember router on a stick, sub interface. Ah. There we'll have tagging. Anyway, one thing I want to clearly show you here is you can configure COS on a router. Yeah. So let us go and change the policy map. This is the policy map. And I'm going to remove that COS. Instead, I'm going to say IP precedence. You are okay with that? I'm going to remove the COS file. Wait a minute. Oof, sorry. I need to say again. I already removed class. PC-R-L set IP precedence. Instead of COS, I'm using precedence. If you want to use COS, you need to have a sub interface on the outbound interface and .1Q enabled. I don't want to get into that area, so IP precedent 5. If you want, you can put question mark and see. You see, 5 means what? Critical. 1 means what? Simple prioritization. 2 means immediate precedent. So more, the 7 and 6 are more prioritized, but this is for network control and inter-network control. That's why I'm giving this critical thing, 7. You can type 7 or you can type critical. So you can type 5 or you can say critical. Both are same. Yeah. Okay. I said critical. Did I say 5? No. All right. Now let us try applying inbound on the interface Ethernet 00. Service, don't put space, policy map name is this PC to PC. Enter. See, layer 3 it accepts. You understand? Input. So layer 2 router don't accept input, or outbound also it will accept only if it is .1Q enabled or ISL enabled. Those are trunking protocols. Fine. Now let us go to verify this. Show policy map that we have applied on interface Ethernet 00. Look at this. On Ethernet 00, you have a policy map called PC to PC. In that, you are calling a class map, and that class map is matching the access list. We have not set any rate limit, so all are 0 bytes. You can accept any size. And if that access list matches, what it is going to do is, it is going to mark 5. It is going to simply mark and say this is important. And you see, so far no packet has been marked. Correct? 0. Marked packet 0. If I'll now go and ping and come back here, I'll see some packets marked. That is the proof. Do you agree? Let's check. Ping again. It's pinging 1, 2, 3, 4, 5 packets. Now let's go here. Look at this. So we have marked the packet. If this packet goes through a queue, the queue will give first preference to this packet. If there is congestion in the queue, it will drop the one which has got low marking or zero marking, no marking, and it will protect this traffic from getting dropped because it has got marking of 5. Did you get an idea now how to configure, match, and set, and then apply? Hmm. You have not applied to so far any queue. See, whether you have applied any queue or not, there is a hardware queue. On every interface, there is a buffer. If that buffer is busy, for example, it is going out on which interface? What is the name? Uh, Going out on which interface? My friend, where is the source and where is the direction and what is the destination? On which router we are in? On E01, if I go now, you don't need to go. When the packet goes, if that E0 is 01 is too busy, because this has got marking 5, it won't drop this. There is a hardware queue, there is a buffer, there is a tunnel, there is a hardware buffer. If I told you in the beginning itself, QoS will be effective only when there is a congestion. Do we have congestion now? Yeah. So now there are few QoS methods which we need to discuss next. But I would like to go to router 2 now and continue the QoS which has already been marked with providing some bandwidth reservation. Listen, when traffic is coming from router 3 to router 2, the packet is already been marked with IP precedence 5, isn't it? Now, I want to receive that in R2. For that, what I need to do is, first of all, I need to go to router 2 and tell accept it. I need to tell to interface Ethernet 00 IP precedence. No. No. Come on, I want to. There's a command called trust. IPQS. Trust. I think it is only in the switches. Let me show you on the switch. Interface Ethernet 01. See, R3 is marking and sending to R2. R2 will be forwarding with the marking. I want to tell the switch. Just trust and signal. IP or QoS. Command is like this: MLS QoS. Maybe a multi-layer switch then. This is a normal layer 2 switch. Sorry then. Let's go back. So I go to R2 now, and now I'm going to say class map. I'll say QoS marked from R3. I'm going to say match IP precedence 5. Meaning, if you see any packet with IP precedence 5, policy map, bandwidth reserve, class, call the class, no set, bandwidth. How much bandwidth you want to give? I want to give 10% or 5% is enough. Now I need to apply this on the outbound interface. So I'll go to the interface Ethernet 01 of router 2 and say service policy bandwidth reserve. So service policy out bandwidth reserve. You got it? Now let us go and check. This is Ethernet, right? What is the actual bandwidth on the link? Let us check. Show interface Ethernet 01. Let's see the actual bandwidth. The actual total bandwidth is 10,000 kilobit, which means 10 meg. I have said 10% of it, which is 1 meg. Let's see. Show policy map on the interface Ethernet 01. You see 500 kilobits. You understand? I said 5%, not 1%, 5%. What? Let me show you. Look at this. No, I don't make anything. Now you see, it says this class is applied on this Ethernet 01, and if a packet is coming with IP precedence 5, so far no packet has come, and you see automatically a queue is created. And what is the limit of the queue? 64 packets in that queue. And what is the size of the bandwidth of the queue? It is 5 meg. Now I'm going to ping from the PC here. After pinging, I would like to show you again in R2. Earlier when I was showing you, was there any matching here? All 0, 0, no? But now, you see, 5 packets got matched. 5 packets came in, and the size of the packet was 490 bytes. The 490 byte packets were marked with, were coming with the marking of 5. For that, it has given this reservation. No drop, because even the queue, didn't form. Why? Because the congestion didn't happen. That is why all 3 are 0. Rest of the traffic, for example, if I ping some other destination, I'm pinging another destination, 10, 23, 23, 2. Now it won't increment. Now, will that This is 5 earlier. Sorry, this is 5 earlier. Even now it will be 5, but it will increase here. That is what called as class default. You understand? We'll stop here today.